All right, welcome everybody. We're getting started with the nematode webinar today. I'm Wendy Wilbur, State Master Gardener Volunteer Coordinator, and we're joined today by Lynhe Demesyeux, and she'll present as soon as I do the introductory slides. So Lynne, we should have probably a couple hundred Master Gardeners on the webinar today, and then they will be able to watch this as a recording later on during the year to get the information as well. So that's great. All right, everybody. So we're going to go ahead and get started with the webinar. I would like to ask you, have you ever experienced any nematode effects in your landscape or garden? And if you have, go ahead and pop that into the chat. And also let me know what county you are joining us from. Well, from Gilchrist County and from Tampa, welcome. And Laney's had nematodes in Orange County, yes, in Duval County. Yep, we've got folks from Alachua, Clay, Palm Beach. Seminole has definitely had nematodes in their soil or their garden. Volusia, yes. And Leon, yes. Jackson County, yes. Osceola County, yes. Hi, Babu is joining us from Lee County. Good to see you. Indian River County's had. Duval County has had them. Rita from Brevard has had them. St. John's, Sarasota, yes to nematodes. Well, at least they're equal opportunity. They are joining us from all over the state. So welcome everybody as you go ahead and log in from as far away as Santa Rosa County, far south as Lee County, Charlotte County is here. So let's see if I can get us going. So after we go ahead and log in and say where we're from, we're going to limit our use of the chat box. So we will be using the question answer box. And so please do that. And that's where we'll be putting the questions for Lynne to answer. Okay. And today our presenter is Lynhe Demesyeux. She's a graduate student in the Crow Laboratory and Nematology Lab. That's Dr. Billy Crow, and she is a PhD, and she's in her third year doing research there. She did complete her master's in August of 2019 in UF Horticulture Science. And she is a sponsored student from UF AREA, which is a program from Haiti. And the tagline for that is feeding the world. So Lynne, we're so thrilled that you can join us today and share your knowledge about nematodes and the impacts that master gardeners often experience or may have to diagnose in the plant clinic. So thank you so much for being here. I'm going to go ahead and stop share. And then if you'll go ahead and share yours, you can get going. I can see it.
Okay. Hi, everyone, and thank you, Wendy, for the invitation. I'm very glad and happy to be able to share my knowledge with you. If at any point you have questions, feel free to put them in the Q&A box, and I'll do my best to answer. For today, we have 5 major objectives. We will first define what plant parasitic nematodes are and how they damage plants. And we will learn to recognize plant symptoms resulting from plant parasitic nematode damage. And also we will go through how to manage plant parasitic nematodes with different strategies for various crops. We will describe how solarization of the soil work as part of management techniques for plant parasitic nematodes. And also, we will go through how to do proper sampling so we can take advantage of the diagnostic capabilities of the University of Florida for plant parasitic nematodes. First, the first section for this talk is the life cycle, general information on plant parasitic nematodes. Okay, nematodes are pretty ubiquitous. They are found everywhere where there's life on Earth, but the vast majority of the non-nematodes are found in the soil, 50%. The rest is divided between animal parasites, some free-living nematodes in the soil and freshwater, and only 10% of the non-nematodes actually feed on plants. And we have good guys versus bad guys. In the soil, if you take a soil sample or a nematode sample in general, you will find bacterial feeders, fungal feeders, some nematodes that feed on nematodes, we call them predators. So for us, these are harmless, and we consider them as good guys. However, there are some nematodes that parasitize animals, including humans, and also some that parasitize plants. For us, those are considered as bad guys. They are harmful. So the nematodes that feed on plants are very different from the common worms that we know, like earthworm, because they are unsegmented, transparent, and generally they are microscopic. We cannot see them with bare eyes. They are recognized by this organ, the feeding organ, that is like an hollow needle that the nematode use to feed on the plants. They are called, this organ is called a stylet. And in the soil, they live and move in a film of water that is surrounded with soil particles. When they attack the plants, they inhibit the wood growth and result in poor performance, plant performance. The general life cycle of a plant parasitic nematode starts with an egg. For some nematode, it will be different, but in general, this is what we have. If we start with an egg laid by a female, a second stage juvenile will emerge from that egg, and then they will molt into a third stage juvenile, fourth stage, and they will go into adult nematode. And generally, the infective stage starts at the second stage larvae, and they will be feeding on the root system of the plants. They will choose young roots, and usually they will be feeding at the most vulnerable part of the plants, which are the tip of the roots. And as the plant grow new roots, they will attack those new roots. And this will result in symptoms that we can observe. The symptoms may be different depending on the nematode that is attacking the plant. And the female will be fertilized and the cycle continues. So for plant parasitic nematode, as I say, you can observe here better the feeding organ that is called the stylet. The nematode will use this organ to insert the plants, and while inserting this organ into the plant, it will release some digestive enzymes that will help soften the plant tissue to be able to extract the wood content and then feed on the plant. Most nematodes will feed on the root system. However, certain nematodes, such as Aphalencoides, will feed on the leaves, buds, and flowers. As you can observe here, this is a pretty typical symptoms of Aphalencoides damage, which is a vein-limited lesion that you can observe in these plants. here in these photos. And most common plants affected here in Florida will be chrysanthemums, cornflowers, certain ferns here as East Indian ferns and azalea. In the soil, we have different groups of nematodes. Some nematodes will feed directly in the outside layer of the roots. We call those ectoparasites. And other nematodes will be inserting themselves into the roots. Some will be tunneling inside the roots. They are called migratory endoparasites, and others will just insert themselves and stay in one position to feed. So we call those sedentary endoparasites. Examples of ectoparasites are sting nematode, stubby nematode, owl nematode. Excuse me, I'm moving this here. And wing nematode. For migratory endoparasites, the ones that move inside of the woods, we have lesion nematode, lens, burrowing nematode, and foliar nematode. Foliar nematodes not inside, they will not move inside of the wood, as I said, because they feed on the leaves, but they will be moving in the leaf tissue or buds or the stems, but I put them here just to say that they will not stay in just one position. Once inside of the plant tissue, they will be moving. And for sedentary endoparasite, examples are woodnut nematode, citrus nematode, cyst nematode, and reniform nematode. So how do plant parasitic nematodes affect or damage the plants? As you can see in these photos, once the plants are affected by nematode, you will see clear difference in the root system of a plant that is not infected and another plant that is infected by nematodes, as they feed directly on the leaves. When plants are infected by nematodes, their performance will be lower because they will not have the ability to absorb water and nutrient as if it was healthy. And again, here is a root system that is without nematode, and to the right, you have a root system that is affected by nematode. A plant that is infected by nematode will show us above ground symptoms. They are similar to other problems, such as other disease symptoms and drought or other general stress. However, it's a first indication that you might have nematode. Those above ground symptoms include yellowing, stunting of the plant, which is poor development of the plant, premature wilting, thinning, and sudden death of the plant. So this can be indication that you have a problem. This is a first sign you can say, I may have a nematode problem. So you can remove the root system to check if nematode are attacking the plants. So the below ground symptoms are also indicative of nematode issues. For instance, certain nematodes will produce galls, as seen in this first photo, which is a modification of the root system here. And other nematodes, such as lesion nematode, will leave some lesion on the roots, can have different colors, some are pink, and as the damage progresses, you can see that it turns brown. And for plants, such as carrots, you can have wood deformation, forking, etc. So the rate of decline of the plant, a plant that is infected by nematode, will depend on the nematode species. Some nematodes are more aggressive than others. The population of the nematode, if you have only a few nematode, even if it's very aggressive, the plant might not decline as the same rate as if you had a huge population of nematode. It will also depend on the susceptibility of the plant, the soil temperature, because is in a warm region such as Florida, the nematodes population tend to be lower during winter, so you have less damage during these periods, and also presence of other stress. If the plant already has other issues, the declining rate will be higher. So now that we've seen symptoms and how nematode can damage plants, we can move to the management strategies that we can use to control them and reduce their damage. So certain nematodes, as I said previously, will give us very obvious signs that they are affecting the plants. For instance, wood knot nematode. Certain species will produce very big galls in the woods. And the galls can be small also depending on the species of the wood knot nematode and also depending on the plant that they are feeding on. Susceptible plants include tomatoes, potatoes, okras, beans, squash, carrots, etc. So in the second photo, I want to highlight the egg mass. This is the female nematode, and you have the egg mass here outside of the wood system. This is the adult female, which has produced the egg mass outside, which is a close-up of what is happening here in the first photo. However, as I said, some species will produce small galls, but also depending on the plant you have, you can have smaller galls. For instance, in grass, the galls produced by a wood knot nematode will be very small, and it might be difficult to see if you are not familiar with this type of damage. In onions, the galls are barely noticeable. However, the bulbs will be smaller than on healthy onion. And in potato, in order to see those damage, you have to do a cross section, and you will see the speckling, which are the feeding sites of the nematodes. And now here, I want to show you two different features. In the first photo, you have galls caused by wood knot nematode. As you can see, the galls become part of the wood system. They are part of the woods. However, in the first photo, you have rhizobium nodules. These are not caused by nematodes. They are a feature that help fix nitrogen in the soil, and they can be picked easily from the woods. They are not part of the wood system. Generally, legumes, this type of nodules are found in legumes plants such as beans and other cover crops. So here in Florida, we have numerous plant parasitic nematodes that attack vegetables. Let's observe together this table here. In this column, we have the nematodes, and across we have different vegetables. Wood knot nematode, as you can see, attacked almost all type of plants, especially the vegetables here. They are all affected by wood knots, and obviously at different levels depending on the wood knot species and also depending on the crop. Sting nematode is also a common nematode here that feeds on this type of different crops, except okra, and sweet potato. Stubby root nematode is also pretty common, but they will not be found in carrot, cucurbits, and sweet potato. Root lesions are not as present as the other nematodes, all nematodes, lens, and reniform, but they can still attack certain crops. So if you want more information on this type of which nematode affect which vegetable, you can see the nematode management in the vegetable garden table 1. So what type of strategies we can use to manage nematodes? There are different management strategies such as chemical controls, sanitation, soil solarization, cover crop, organic amendment, crop rotation, and the use of resistant varieties. However, no one option will resolve all the nematode infestation problem that you have. So this is why it is recommended to apply an integrative approach to control nematode whenever it's possible. There's no silver bullet. So for the first one, we are going to talk about sanitation and prevention. If possible, it is recommended to start with clean planting materials. So if you are going to use seeds, make sure that the seeds that you are using are free of nematode issues. And then when we move to sanitation, it is recommended to use clean tools in between locations. Nematode move very slowly, but the activities that we do can help in the progress of these nematodes. So we can move them from one location to another by transporting soil and infected plants from one location to another. They can be moved also via irrigation water and via the tools that we use in between locations. So once we finish to use equipment, it is recommended to power wash them or to use a disinfecting solution such as this 10% bleach solution to clean up the tools in between location. And once we finish with the crop cycle, it is important to destroy those plant materials. We are not going, if the plants are infected with nematode, we are not going to be using them in for composting because we will continue to distribute those nematodes in the locations that we use this compost. Another method for controlling nematode is soil solarization. This strategy implies that we use heat to eliminate plant parasitic nematodes and other nuisance that is in the soil. This is achieved by increasing the soil temperature between 95 to 140 degree Fahrenheit. However, the ideal temperature will be 135. So how it works is to use a transparent plastic to cover the soil at a depth between 4 to 12 inch, and we leave it for about 6 weeks, but the longer the better. The solarization will work best in summer because during summer we have longer hours and also the temperature tend to be higher. So it will not work in shaded areas. Like in the first photo, you can see that there is a fence close to the bed that they are trying to solarize. This will not work because the fence will reduce in the temperature that could be achieved. This is a better practice. Away from the shade so we can take advantage of the full sun. And it is also important to try to reach 12 inch deep, as I said, because most of the root system of the plants that we grow will be distributed in that profile. So the solarization will eliminate all living organisms in the first 6 inches, including weed, disease pathogen, insects, but it will also affect beneficial organisms, but this will tend to recolonize pretty quickly, so it's not really an issue. For the solarization, I'm going to give some example on how it works on certain nematodes. Studies have found that Meloidogyne incognita is controlled after 390 hours, and Meloidogyne javanica is killed instantly at 122 Fahrenheit. The egg dies after 2 to 3 weeks in average temperature of 109 Fahrenheit. And I want to highlight that one solarization will not will not solve all your nematode problem, because right after the first cycle, the nematode population tend to grow again. So you will need to integrate other control method to continue to control the nematodes in the soil. They also have found that solarization followed by a cover crop such as cowpea tend to suppress the root knot nematode, as if you applied a methyl bromide, which is a very potent fumigant that is not used as well here as before. Another management strategy is organic amendment, added as compost, manure, or green manure. The addition of organic amendment will enhance the soil microbe and beneficial nematode, which is good for plant growth. And they will also increase some chemical toxic to nematodes such as brassicas. And even if plant parasitic nematodes are unaffected by organic amendment, is still a good practice to use them, as they benefit the soil health and structure, and also the plant health. Here I'm giving the results of a research that my advisor conducted with comment and also with peat. In green, we have 40% of comment, and in red, 20% of comment, and in blue, 15% of peat. As you can see, this study lasted 18 months. At the beginning, the 2 percentages of comment provided a good control of nematode per cc of soil. And after basically 1 year, you can see that even the 20% of comment added, which is a compost, decrease the nematode content in the soil. So it is a good practice to use comment. Another management strategy will be the use of cover crops. They are usually used in between of growing seasons, and they help with they have a lot of benefits. It's not only used for nematode management, because they help to improve the soil fertility and structure. It helps also in decreasing erosion. It helps to suppress weeds, insects, nematode, and other disease. And they can be incorporated also as green manure. As I showed previously, some legume cover crops will produce the nodules that I showed previously, and they will help fix nitrogen in the soil, which is good, and because it increased the fertility of the soil, and the next crop will benefit from this fixed nitrogen. Certain cover crops have nematicide property. For instance, cowpea may help with wood knot, but it will depend on the species of wood knot present in the soil, but it will not be as effective for sting control. Sun hemp will be very effective against wood knot and also against sting nematode. Sorghum control wood knot, but not so much sting. Marigold, depending on the species of marigold and also the species of the wood knot, you may have good control, but does not suppress sting population. Velvet bean helps with wood knot and sting, and rye and bahia will help with wood knot, but not sting nematode. If you want more information, you can follow these links, and you will have more information on what cover crop you can use, which cover crop you can use in which crop. More nematicide cover crop, you have hairy indigo, which will provide good control for wood knot, again, depending on the species of wood knot you have, and good control of sting nematode. Pangola will also give good control of wood knot, but not so much on sting, and so on. Okay, here, what I wanted to say about cover crop is some people think that if they plant the cover crop in between rows of vegetables, then the cover crop will work. It doesn't work like this. You have to plant the cover crop first, and then you follow up with the crop that you want to use. If you just incorporate it in between your crop, it will not work. Now we move to the use of resistant varieties. Before you choose one resistant variety, you have to know which type of nematode you have. Even with wood knot, some resistant varieties will work only for on some resistant varieties of tomato, for example, will be resistant to only a few species of wood knot, and we have different very aggressive species of wood knot. So it's important to know which type of nematode you have, so you can choose the appropriate resistant variety. And at the end of the crop cycle, it is important to destroy the wood system that is infected in order to suppress the nematode population. And if you still have, after incorporating different management strategies, you still have nematode issues, it is recommended to use containers to plant. But if you use containers, it's not recommended to put them directly on the soil, because the nematodes can still go through the pots and then affect the plants. So how do we not manage nematode on turf grass? It's a little bit different. So first, we have to observe if we have nematode symptoms. In grass, the nematode symptoms can be a little bit different, but the most common symptoms that you will observe will be irregular shaped in the grass, and also you might see that you have more weed, because the dying grass will leave space for weeds to grow. So if you have a patch in your turf grass that is full of weed, you might have nematode issues. You will also observe yellowing, wilting, which will result in plant death. So those can be indicative of nematode issues. So as below ground symptoms, they will be similar to other crops. You will observe shorter root systems. The roots will be stunted, darker in color, etc. And if you have wood knot nematode, you may also observe wood galls, but they will be very small. And this is, again, another photo showcasing irregular patches that are affected by nematodes. The symptoms will be similar to the drought or water to drought symptoms. And in areas where the water is controlled, the symptoms will be more evident. As shown in this photo, since the roots are so small, they cannot go deeper in the soil to feed the plant, which will result in declining plants and showing more pronounced symptoms. And nematode, you can bring nematode in your location when you purchase sod farm. However, it's not, since you cannot test it, it's like you cannot prevent this issue. Some turf grasses are more susceptible to nematode than others. So in your area, you have to know which type of nematode you have, and this can help you choose which type of grass you can use in your area. For instance, barrier grass is one of the most tolerant turf grass we have to plant parasitic nematodes. However, zoysia grass is very susceptible to sting, wood knot, stubby wood, lens, etc. So here is a table that gives us an idea of grasses that are susceptible and others that are less susceptible than others. For instance, here centipede is very susceptible to wing nematode. However, these other grasses are not as susceptible as centipede to wing nematode. Usually wing nematode affect higher plants than like forest plants. They are not as prevalent in grasses. And when you start to have issues in your grass, you will observe weeds, as I said, and certain weeds are very tolerant to nematodes. So they will continue to grow because the nematode doesn't affect them. They will colonize the space that is left by the dead grass. And in order to control the nematode, it is recommended to remove those grasses because even in the absence of the grass, they will continue to grow because the nematodes can feed on them. And you will have higher population of nematodes. As of 2024, there are some label chemicals that you can use to control nematode. And again, it is important to know which type of nematode you have, as the control will depend on the type of nematode present in the soil. For instance, a Xelto in crescendo will give good control of root knot nematode. However, Nimitz will give better control of sting, lens, and wood knot. So it's important to know which type of issues you have. And I'm not I cannot offer knowledge on this type of control. If you have issues, you want to know which type of chemicals to use, please contact my professor, because I cannot talk about this type of information. And how to manage nematode in ornamentals. For instance, some nematodes, some ornamentals will be more susceptible to nematodes. Butterfly, bush, hibiscus, boxwood, those are common ornamental that we use, but they are also susceptible to nematodes. Plants like gardenia and roses are usually planted on resistant rootstock because they help to control nematodes. Some landscape plants that are less susceptible to nematode are Walter viburnum, sweet pepper bush, fire spike, gold dust, cotton, oak leaf hydrangea. You can have more information if you go to the UF IFAS research pages, EDS. They have plenty of information on what type of ornamental you can use that are less susceptible to plant parasitic nematodes. Some bedding plants that are very susceptible to wood knot nematode include coleus, celosia, pansy, snapdragon, petunia. And again, if you want to know which bedding plants are susceptible to nematode, you can go to EDS and you will have an idea of what you can plant and what will be more susceptible. As you have bedding plants that are susceptible, there are also bedding plants that are resistant to multiple wood knot species. For instance, Ageratum, Alyssum, Dianthus, Vinca, Salvia. Those plants are good choices against wood knot nematode. To continue, to manage nematode in ornamental, you can use chemicals, but there are no labels chemicals for to manage ornamental plants, nematodes in ornamental plants. If you are using choosing a plant, you have to know which plant you can put in which location, because it will depend on what nematode you have in this location, so you can choose plants that are resistant to said nematode. And you can also rotate bedding plants. You can alternate from resistant plant to susceptible plants, because if you plant the resistant crop before, it will reduce the nematode population, and then you can plant the other crop. If you are able, it is recommended to solarize the soil on annual plant beds. And also the use of organic amendment is very important. As we said previously, it's not only help with controlling nematode, but it is also good as it increase the soil fertility and also soil structure, and it can also add beneficial organism to the soil. So the use of organic amendment is highly recommended. And at the end of the crop cycle, it is important to remove infested roots and soil, and also, if possible, grow the plants in containers. So now that we know the symptoms that nematode can cause, we know also how to manage them, but it's important to work on the diagnostic part. As I said, some nematode, to have an effective control, you have to know which type of nematode you have. So to know that, you have to submit your plants for diagnosis. And the nematode are usually, as I said, microscopic. If you see, you can say, hey, I have nematodes, but you will not know which type of nematode you have. So for that, it's important to send your sample for diagnostics. And how do you do the samples? Usually, it is better to do the sampling at the end of the crop cycle, because at the end of the crop cycle, this is when you have a better picture of the nematode population that you have in the soil. And for good diagnostics, both soil and roots are needed. And you will be taking the samples around the drip line of each plant. Soil sample should be taken at a depth between 8 to 10 inches, because this is where most of the root system is found. And it's not important to include the first inch of soil, because it's usually dry and compacted. So the nematodes will not be in that first inch of soil. Make sure that the roots that you are including come from plants that are that you want to analyze, not from the weeds that are around. And you have to also place the soil and the roots in the same plastic bags, and minimum of 2 cups of soil, but the more the better. So here, you have an infected turf grass, right? And the symptoms are showing. So to send, how do you take the samples? You have to follow the patches, the irregular patch. Here you have dead plants. So if you take the samples here, most likely you will not have a good representation of what is happening, because you have less nematode here in where the plants are dead. So it's important to go at the edge of the patches to have a better representation of the nematode population. So once you have the samples, you have to send them as soon as possible, because the sample will tend to dry, and you will not have a good picture of what is happening in your location. And if you were not able to take the samples at the end of the crop cycle, if you are taking it before planting, please follow a zigzag pattern so you can have an idea of a representative result of the location. For instance, consider that this is the space that you were sampling. If you follow the zigzag pattern, this is what you can have. You will have location where you have high number of nematodes, but also there are locations that have only 4 nematodes. If you took only one sample, it might give only 4 nematodes, and you might say, hey, I don't have a nematode issue. However, you could have as much as 700 nematodes. So this is why it is important to go in a zigzag pattern, so you can have a more representation of what is happening in the soil. Because the nematodes are not distributed evenly in the soil. For each location, it is recommended to take approximately 16 cores, and also take it between 3 to 4 inches, or if you can, go as deep as 10 inches. And the accuracy of the diagnostic that we will provide will depend on the quality of the sample that you give us. Sampling depth, again, normally before planting, it's important to take the samples between 8 to 10 inch deep. Post plant, it will depend on the crop. Think about how deep the root system is. For annual crop, vegetables and annual bedding, 6 to 8 inches is important, is okay. However, for trees and shrubs, you have to go a little bit deeper because they have bigger root system and tend to go deeper in the soil. For turf, however, 3 to 4 inches is enough. And I want to focus again on the right time of sampling. Nematode population fluctuate throughout the year, and they may be undetectable during winter or early spring, and they often increase to very high population during summer, late summer, and early fall. So once we have the samples, this is how we extract the nematodes. For a soil sample, we need about 100 cc of subsamples. We mix together the samples that you send us. We take 100 cc of subsample, we centrifuge, and then we extract the nematodes. For the roots, we will use another method to extract the nematodes, which is a mixed chamber. And we use approximately 10 grams of roots per sample. Okay, what are good samples? What are bad samples? So please don't do this. Don't dry the soil before bagging them. Once you pick them, once you take the sample, you mix them, you put them in a bag, it's not necessary to dry them because you risk to kill the nematodes. Put the samples in a large box so it can rattle during shipping. If taking multiple samples, don't label the bags. Let the lab figure it out. If you are shipping in a Ziploc bag, don't put tape over the zipper. Hopefully it won't open up in transit. Send grass clipping instead of soil. Collect less than a pint of soil. Don't do that. Send us more samples. And sample in the areas of the grass that are dead. You will not get good results. And don't samples also in the healthy regions. You have to go at the edge of the patches. Don't keep the samples in your dashboard to bake in the sun. Don't send the samples without a without a form. Don't send the samples out on Friday because we don't work on Saturday and Sunday, or just before the holidays. So results are provided in that manner: number of nematode per 100 cc of soil, number of nematodes in 10 grams of woods, and we will also provide the risk level depending on the nematodes we have. And this is the form that you have to fill out for the diagnostic. Please put as much information as you can. And you can find this form at this website, which is the Nematode Assay Lab website. And I want to thank my professor, Billy Cole, to help me practice giving presentation. Thank you to Wendy, and thank you all for your attention.
Wonderful, Lynn. Thank you so much. Are you comfortable taking a few questions?
Yeah, sure.
Okay. Everyone is really enjoying it. Let me see. I think Billy was jumping in and answering some of these, so I'm going to double check. Can you speak about using yellow mustard planted as a cover crop to suppress nematodes?
Yellow mustard.
Let me jump in and handle
Oh,
that one.
okay, thanks, Billy.
Believe it or not, actually, that was part of my master's research project decades ago, believe it or not. So, so certain types of mustard plants, plants in the mustard family, contain high levels of glucosinolates, which, when they break down in soil, form a volatile biofumigant. Okay. However, the mustards that we grow in Florida are not high in glucosinolates, and they don't have that nematode suppression. These are certain cultivars they use up in Canada and in the north, but they don't grow well down here. And so your regular edible mustard plants you did would not do good for that purpose.
Okay, great. And so from Lynn's presentation, I think we really learned that there really isn't a soil treatment that we can do for the homeowner. Is that correct, Lynn?
Sorry?
Is there a treatment that someone can just like a magic spray that they could put on the soil for nematodes?
No, as I said previously, it is better to incorporate different treatment methods. And also, we don't have a lot of chemical nematicide or nematicide in the market. For homeowners, it is better to practice solarization if possible, use organic amendment, use the right plant. For instance, if you see that you have a nematode issue, try to choose from plants that are resistant to nematode, and try to alternate between susceptible and resistant plants, and you can have better control of those nematodes. There is no silver bullet when it comes to nematode management.
Right, and then really looking at that crop rotation in the vegetable garden, selecting those nematode resistant or tolerant varieties. And when you all are shopping for your seed packets, to look for the letters on the seed packet that say probably have an N on them, and that means that they are more resistant to nematodes. That would be great. Go ahead.
And also, if you are using the tools that you are using, if you're sharing with a neighbor or something, it's important to disinfect them before using them in your location. They might have an issue that you don't have. So before using them, it's important to clean those tools. And
Right.
And I
And then,
think Lynn mentioned this also, but with that VFN, though, that's only resistance to 3 species of root knot nematodes. However, we have some invasive root knot nematodes that are now becoming more and more common in Florida that resistance does not work for. So if you have root knot nematodes, definitely go for that, but realize that you may hit up if you have the wrong type of nematode, it doesn't work. So that's one of the problems we're having. I've been working with one of the seed companies that's just came out with a new root knot resistant pepper cultivar, and so they wanted us to sample different farmer fields that are thinking about using this pepper. And every field we sampled had the nematode in there that the resistance doesn't work for. So yeah, they're becoming more and more of a problem.
yeah. Which is the reason why, Lynn really emphasized the cultural methods to really improve your growing conditions as much as possible. And a good question about using clear plastic rather than black plastic, if you all would address that for solarization.
yes, for the solarization, the objective is to capture the heat from the sun. So it's important to use a material that can really help increase the soil temperature. Do not use a reflective type of material. So in that way, you will not be able to increase the soil temperature. And so some materials are better than others.
And then someone is asking about some of the beneficial nematodes that are out there.
What was the question about that?
Could you talk a little bit about beneficial nematodes in the soil?
Oh, okay. So we have the beneficial nematodes usually are called free-living nematodes. We have some nematodes that feed on bacteria, other that feed on fungi, and some nematodes, predators that feed on other nematodes. So they can be used to control parasitic fungi, parasitic bacteria, and they also participate in the decomposition of material, which is good for plant health and plant growth. So what else I can say?
Mhm.
There's also certain, well, there's actually quite a few nematodes that infect and kill insects that are used in insect biocontrol. I saw some questions in the chat about this. So these are nematodes that go inside insects, then release a bacteria inside that kills the insects. There are certain you got to have the kind of the right nematode for the right insects. But they are effectively used for control of citrus root weevil, for example. And we have other ones that kill mole crickets that University of Florida released, decades ago. But if specific insects, you have to pick out the right ones. So if you want to email me about those, I can try to help you pick those out, but it's kind of more involved than you want to go to in a presentation like this.
Great. Christine, there is a really great article on IFAS on soil solarization. It really walks you through the whole steps and talks to you about the depth, the thickness of the plastic that you need to use. It needs to be pretty good thickness. I think it's 3 mil or above. So that's an answer to that question. And let me see I saw another question about water. And it said, since nematodes need a film of water, are there less nematodes in dry sand than in moist soils?
Yes.
Yeah.
Okay, well, that was quick. Well, let me tell you all, there's some wonderful information on IFAS about nematodes, and then you're always welcome to shoot a sample to the lab as was described to you today. And there are ways to get them identified. And I think Lynn did a beautiful job of describing strategies, techniques, selections for dealing with nematodes in your home landscape. So thank you so much for being with us today. And we will stay tuned for all the hot new research coming out of Billy Crow's lab. So thank you very much, you all.
Thank you for having me, Wendy.
You're very welcome. We'll see you
We
soon, I hope.
answered everyone's question.
Yes. All right. Bye-bye, you all.
Thank you.